Welcome back to The Explainer. I am absolutely thrilled you're joining us today because, wow, we are tackling one of the most mind-bending, universally fascinating concepts out there. We're talking about time, specifically the idea of bending the arrow of time backward. For as long as humanity's been around, we've experienced time as this stubborn one-way street, right? Always marching forward. But what actually happens when you pop the hood on reality? What do the literal laws of physics have to say about reversing that flow? Today, we're going to explore the stunning reality behind backward time travel. We'll be moving from those classic science fiction paradoxes straight into the cutting-edge quantum labs of today.
Okay, let's dive into this roadmap. First up, forward travel is easy. Number 2, bending space-time backward. 3, the grandfather paradox. 4, the quantum loophole. And finally, number 5, sending data to yesterday.
Section 1. Forward travel is easy. The physics of tomorrow.
So to even wrap our heads around going backward, we've got to ground ourselves in the physics of going forward. And I know, it sounds like pure sci-fi, but mathematically speaking, traveling to the future, it's actually a completely solved physics problem. Seriously, if you want to see what Earth looks like decades from now, the blueprint is surprisingly straightforward. You just hop into a rocket, accelerate to a velocity close to the speed of light, and let Einstein's theory of relativity handle the rest of the heavy lifting. Because time moves slower for an object in motion relative to a stationary observer, a super quick trip for you at light speed would literally mean decades or even centuries have passed back home on Earth. You step off the ship and boom, congratulations, you're officially a time traveler living in the future. But that brings us to the real million-dollar question, doesn't it? Going forward is basically just a matter of engineering and velocity. But what if you want to turn the arrow around? What happens if you try to go back and rewrite yesterday? Is it an absolute, hard stop impossibility, or is our universe maybe hiding a few temporal backdoors? Section 2. Bending space-time backward. General Relativity math.
Well, this is where the raw mathematics of general relativity completely flipped the script on traveling to the past. For decades, backward time travel was just completely written off as a logical paradox. A super entertaining idea for movies, but totally incompatible with actual reality. But check out this historical trajectory. Back in 1915, general relativity established the physics of space-time as this fabric that can actually bend and warp. Then, fast forward to 1949, mathematician Kurt Gödel proves something absolutely staggering. He showed that if a universe is rotating, that space-time fabric would naturally warp so severely that its paths would literally loop back on themselves. And as we follow this timeline up to 2026, the math for actually utilizing these loops has just rapidly accelerated.
Gödel's discovery introduced this heavy but absolutely crucial concept to physics: closed time-like curves. Think of these as literal physical loops woven directly into the fabric of the universe. It's wild to think about, but if you were in a spaceship and somehow found one of these curves, you wouldn't feel like you were traveling back in time. You'd just be flying forward in a straight line through space. But because space-time is essentially folded over on itself, your path forward inevitably plugs directly back into your own exact past. It is, quite literally, a geographical shortcut through time itself. Section 3. The grandfather paradox, the causality roadblock. Now, what's really interesting about this next concept is that once you establish that mathematical loops exist, you immediately crash headfirst into a massive roadblock: causality. Let's look at the classic grandfather paradox. We all know this one, right? You step out of a time machine, accidentally step on a clock, and you trigger a chain of events that accidentally erases your own grandfather, and by extension, your own existence. But wait, if you don't exist, you couldn't have ever built the machine to go back in the first place. It totally breaks logic. But mathematically speaking, there's a fascinating counterargument: the Novick self-consistency principle. In this scenario, you step out to break the clock, but your foot slips on a puddle, accidentally causing the exact sequence of events that led to your present day.
Let's break that down a bit more. The Novikov self-consistency principle is a rigorous mathematical framework stating that the probabilities of any event happening inside a time loop actually adjust themselves to ensure paradoxes are physically impossible. So if you try to alter the past, the universe essentially forces your actions to become the very cause of the history you were trying to change in the first place. The timeline remains strictly unbendable. You can absolutely visit, but guess what? You're already written into the script.
Section 4. The quantum loophole, subatomic time loops.
So if massive cosmological time travel traps us in these completely unbendable scripts, where exactly does that leave us? Well, to find a loophole, we have to pivot away from our massive, messy, human-sized world and look down at the clean, microscopic realm of quantum entanglement. Now, this happens when two subatomic particles become intrinsically linked to one another. Regardless of whether they're separated by just a few inches on a lab bench or by thousands of light years across the galaxy, changing the state of one particle instantly affects the state of its entangled partner. They communicate instantly. And this led physicists to recently ask a mind-blowing question: what if they communicate not just across distance, but across time? Modern researchers over at the University of Cambridge took this exact concept and ran with it. They shifted the focus completely away from massive spaceships and human bodies and strictly targeted the quantum scale. By meticulously manipulating quantum entanglement, they set up an experiment to actually test the math behind closed time-like curves. And incredibly, they successfully simulated backward time loop mechanics right there in the laboratory, no spaceships required.
Section 5. Sending data to yesterday. Retrocausal mechanics.
Let's move to the next phase and see how this builds into something even crazier: the mind-bending practical application of these discoveries. Physicists use an exact step-by-step process known as retrocausal mechanics. Step 1, you entangle two quantum particles across time. Step 2, in the present moment, you dramatically change the state of the secondary particle. And step 3, all right, this is where reality gets genuinely strange. That action retroactively alters the historic quantum state of its entangled partner in the past. Think about that for a second. You are effectively pulling a lever today that physically moves a mechanism yesterday.
Building directly on this retrocausal foundation, recent studies from physicists at Cornell and MIT have taken this whole thing to the next level. They've mapped out the precise mathematical framework for sending information backward. By utilizing what they call noisy closed time-like curves flowing through quantum channels, their models show that data can be successfully pushed into the past without triggering any of those messy paradoxes we talked about, all while maintaining complete quantum stability. Now, to be super clear, we are not talking about building a time machine to launch a person back into the 1900s. We're talking about utilizing quantum properties to send raw digital messages backward. We are talking about data.
Which brings us to our final thought for this explainer. As the source material so eloquently puts it, quote, "We may not be stepping through temporal portals anytime soon, but the code for rewriting yesterday's data is already sitting on a blackboard." The macro world we live in, the world of ticking wristwatches and aging bodies, well, it keeps time flowing stubbornly in one direction. But at the foundational, quantum level of reality, the equations just simply do not care about forward or backward. Time isn't some rigid one-way street, it's a fluid canvas that actually allows for loops, shortcuts, and echoes. And if the mathematics of retrocausality continue to hold up in the lab, I'll leave you with this one question to ponder. If you could securely send just one line of digital code back to yesterday, what would you change? Thank you so much for exploring with us, and keep questioning the reality around you.